Welcome back from an ad break. You're still watching Excel Live right here on channel 263. Your number one, biggest, the baddest, and the most hip and happening. My name is Lama Lee Moon. Welcome to it. It's SciTech Wednesday, and we're bringing you everything scientific. Right now, I'm chilling with Dr. Patel, who's fascinated by cheetahs, and why that happened, we have no idea. So he's here to tell us more about it. Le research yakhe let him to find ukuthi angayidibanisa ne-robots to learn more about what that tail does. And lately, he thinks that we can do the same with human beings. Welcome to the show, Doctor. How are you?
Thank you for having me. I'm very well, thank you.
Cool stuff. First and foremost, your love, was it for sciences, robots, or animals? Because we're talking cheetahs now.
Yeah, no, I actually, so I started out wanting to build robots, so the best robots, and then I thought, how can we build the best robots if we don't build the best or understand the fastest animals? So that's when I looked at the cheetah, and I saw that there's actually not much known about the cheetah.
Yeah.
So especially the spines and the tails and all the interesting things about them. So what I did was I developed some systems in order to understand the cheetah. So sensor systems like these, so that we can place sensors on the cheetah and then also have videos on the cheetah to analyze how it moves in order to build better robots. And in that, I must be honest, I sort of fell in love with understanding animals and how exciting they can be. So yeah, that's where my story.
What methods did you use to find actual facts about the robots and the cheetah's tail?
Yeah, so we kind of took it on two fronts. So the one was we used robots and we did similar motions to the way that the cheetah moves its tail. So if we swing the tail in this direction on the robot, we see that it makes the robot more agile. So that tells us that the cheetah is indeed benefiting from the tail. And then also we wanted to see what do the real cheetahs do. So one part of that is to develop these sensor systems, placing the sensors on the cheetah to see how often does it flick the tail, how fast does it move the tail, and so on. And then also we actually did real tests with real cheetah tails.
Is this a real cheetah tail?
This is a real cheetah tail.
Okay, cool.
That we've preserved, and we placed these in the wind tunnel. So when you have your car and you're trying to test its aerodynamics and so on. Similar thing with the tail. So we put the tail in there and we determined that the tail actually produces a lot of force because the cheetah is moving so fast that it can use like a rudder, like an aeroplane. Similar idea, so the cheetah can change its direction using the tail, the fluffiness of the tail.
So your findings, you connected to a robot. So can the robot do what the cheetah does?
Not yet, but we're getting there. So at the moment the robot was still using the idea that for a long time people thought that the cheetah's tail was heavy, so very heavy. But in fact, when we did these experiments, you can see these cheetah tails. We worked with some vets at the zoological gardens in Pretoria, and what we found is that the tail's actually not as heavy as people think. So it's very light, and the idea is that, like I said, it makes a very light tail but a very bushy tail, so it can use the aerodynamics to help it turn and stabilize. So the next part of my project is to use this idea and build a robot with a sort of aerodynamic fluffy tail, to be able to corner faster and be more agile.
You must be so excited. You found your findings with cheetahs. Are there any other animals that you want to study and match with robots and what it can do?
Yeah, so we're very excited about the cheetahs. Obviously, it's very cool. But I've also started a collaboration, and we're going to be looking at dogs. So also dogs are quite agile. How they move so quickly. And then also ostriches, quite interestingly. So an ostrich is the fastest two-legged animal. They're much faster than us.
Yeah.
And we want to know how we could design robots in order to maneuver like the ostrich as well.
What about the tortoise? Is it because it's slow?
It's too slow.
Too slow. So why don't we go and check out this robot and see what it looks like and what it can do?
Okay.
Cool stuff. So now we are at Dr. Patel's lab, and he's showing us Baleka. This is the robot where, it's a robot, but I feel like it's a cheetah. Doctor, who developed this robot?
So this robot was developed mainly by my master's student, Alex Blom. He is now working at a company which develops aircraft flight controllers, quite cool. And then another student, Callan Fisher, who's now a lecturer at Stellenbosch University.
How long did it take to build it?
It took about 2 years, so a lot of mathematics, a lot of equations and stuff, and then computer programming. And then Alex, the cool thing about him is he's actually a mechanical engineer. So you can see this robot, there's a lot of mechanical aspects going into it. So he made sure that everything was correct in order that it could run. Yeah.
Importance of these studies, because you could have been doing something else with your time. However, you decided to.
Yeah, my research is kind of focused on agility and maneuverability. So a lot of guys are focused on, if you think of a car, they're trying to drive the car at the fastest speed, but nobody's thinking of how you get to that speed, so that acceleration, and how once you're at that speed, how you can turn and maneuver. So this robot was specifically designed for acceleration, and also for deceleration, so for stopping. So one, in terms of robotics, like nobody really knows how you're supposed to make a robot run and accelerate. And then two, again, the sports scientists are quite interested in this because it's a nice little mechanical experiment that they can use in order to understand how humans stop and turn and accelerate in order to understand injury. So it has knees and has ankles. So in that way, you can see, okay, if it's getting a lot of force in the knees, maybe we should teach our sprinters or our soccer players, they should turn in a different way or they should stop in a different way. So yeah, those are just two of the implications of the robot.
Are there any benefits for normal or regular citizens from this, like Peter and Paul walking outside? Are they going to benefit from these research and studies?
Yeah, not immediately. But like the sensor system, we really don't know where this is going to go. One thing is that we've developed some quite interesting algorithms to actually control it. So in order, like AI, if you think of it like that, to move this thing, and that can be applied to many different things such as manufacturing, mining, even medical robotics. All those things can benefit from something like this. So that's what I love about research, is that, again, you don't know where it's going to take you, but it's really, really exciting and fun.
Before we go back to the studio, let's see how this robot works. Keep it locked. So what do we call this study, your research?
So overall, the research is in maneuverability of robotic systems. Maneuverability of robots and animals.
What's next for Dr. Patel?
Lots of things. One thing I'm quite interested in is how we can use ideas from artificial intelligence to understand animals. So particularly, I just wrote a paper now on using deep learning, which is a way of modeling our intelligence and applying that to understanding how cheetahs move. So that's sort of the direction that I'm heading in.
Our viewers love getting in touch with the people that inspire them. So if they're watching right now and they want to get in contact with you, where do they find you on social media?
So yeah, we have a really cool Instagram. It's uct.mechatronics, and we're posting stuff every week on, just what we're getting up to in the lab, any new things we're working on, and you can reach out on me there. And then also we have a website, UCT Mechatronics, so it's mechatronics.uct.ac.za.
Okay, and of course you can catch them on XL and Cape Town TV on our Facebook timeline. That is where you'll find most of their details. Right now it's time for us to go back to the studio. This is XL Live.